Okay, here we're going to be talking about units. There are two basic types. The common one is metric or SI units or imperial. Okay, in physics class, we'll not be using the imperial. It may be what you're used to because imperial system has things like inches, feet, so inches, feet, yard, mile, pound. Okay, you may be quite used to these measurements because they're used in the U.S. Actually, only the U.S. and two other countries around the world. But scientists, scientifically, internationally, we use metric unit, or they're also called SI units, and these are meters, seconds, kilograms. I'm sure you've heard of these already. But the nice thing about these is that they're based on the powers of 10. Okay, so they're super user friendly. So for example, here we have 1,000 meters. Okay, that's the same thing as 1 kilometer. Okay, so this 10 to the 3 means 1 kilo. Okay, so this is called a prefix. It's a lot easier to work with prefixes than what we have in the imperial system, which is like 1,000 feet is 0.189394 miles, which is really hard to convert. But with prefixes, it's actually quite easy because kilo means 10 to the 3, mega 10 to the 6, so you have like megabytes, gigabytes means 10 to the 9, centimeters, millimeters, micro, femto, and all that kind of stuff. Okay, but these are just the common ones that you should know. So what are some standard abbreviations and SI units? Well, the first one measures length. Okay, so length, and the SI unit, or this is the meter, not the kilometer, the meter. Okay, and the abbreviation is M in brackets. Okay, for mass, okay, SI unit is kilogram. Okay, so this is a bit of a different. It's not gram, it's kilogram. Okay, so don't get confused with that one. That's a very important one not to get confused with. And for time, the SI unit is second. Okay, and that's just S. Okay, so these are the three basic units that we'll be working with for the first few units. There's 7 in total, and we'll just look at 3 there. Okay, so one thing you're going to need to know how to do is convert from different kinds of units, and there's 3 steps. If you don't take shortcuts, if you do these 3 steps, you'll get it right every single time. Okay, so I'll show a basic example first. If we want 1.5 kilometers to meters, okay, there's 3 steps. First, you write the conversion factor. So 1 kilometer is equal to 1,000 meters. Okay, then you write them as a ratio, and this is what we also call the conversion factor. Okay, so 1,000 meters divided by 1 kilometer is just 1. And so the idea is if we need to convert 1.5 kilometers into meters, we're just multiplying it by 1. So we're not changing the actual value. This is super important to understand. And since we want to get rid of the kilometers, we make sure the kilometers on the bottom, on the denominator, so that they cancel out. And once the kilometers cancel out, all you get on top is the meters. And then so you just multiply through and you get 1.5 times 1,000 meters and you get 1,500 meters. Okay, this is actually be 1.5 times 10 to the 3 meters in scientific notation because this is ambiguous. Okay, so let's do just a quick example, but maybe more challenging. If I have 100 miles per hour into kilometers per hour, okay, well, step 1 is 1 mile is equal to 1.609 kilometer. Okay, so step 2 is to write it as a ratio. So, we want to get rid of the miles and we want kilometers. Okay, so we're going to put the miles on. So 1 mile is equal to 1.609 kilometers. Okay, and that ratio is equal to 1. For this one, we'll need another, no, because we're keeping out on the bottom. So that's all we'll need in this case. Okay, so now step number 3 is to multiply it through. So we have 100 miles per hour times 1, but that 1 is 1.609 kilometers on top, 1 mile on the bottom, which is what we wanted because these miles now cancel out. And if we multiply this through, we get 160.9 kilometers per hour. Okay, so these are pretty straightforward examples. Again, if you follow this 3-step kind of format, you'll never get these wrong, even if they're a bit more challenging.